Okay, now we're going to work through some examples of finding the antiderivative. First of all, we're going to start with the basic rules for indefinite integrals. And these are your rules, and you're going to make a note card on these. But basically, all we're doing is doing the reverse process of taking the derivative. So the antiderivative, or the indefinite integral of 1 dx, will just be x, because the derivative going the other direction of x will be 1. And then don't forget, you have a whole family of functions, so you want to make sure in your indefinite integral answer you have a plus c everywhere. Okay, this is your power rule for antiderivatives. When we took the derivative, we brought down the power, reduced the power by 1. We're just going the opposite direction. So to take the antiderivative, we're going to add 1 to the power, and instead of multiplying by that number, we're going to divide by that power. And then all these are just the reverse process of the trig ones that we have. So the antiderivative of the cosine is your sine, because the derivative of the sine was cosine. So we're just going backwards on all the trig ones that we learned. Okay, properties of indefinite integrals, same as with derivatives. If you're multiplying a function by a number, so a constant multiple, you can just pull that number out in the front, take the indefinite integral, and then multiply afterwards. When you're adding and subtracting terms, you just take the antiderivative of each piece separately and add them separately. Okay, so let's work through these examples. So some of these problems, you may need to rewrite the function first before you can take the antiderivative. There is no product or quotient rule for antiderivatives. So if you see a product or quotient, you will have to rewrite this first. So this problem here, I'm going to rewrite this as x to the 8th. And we have a power rule for antiderivatives, so I'm going to add 1, divide by the power. Don't forget your plus c in my answer. This one here, this is a composite function. We haven't done a chain rule component with antiderivatives, so in order to do this problem, I need to multiply out first. So this multiplies out to 4x squared plus 12x plus 9. Now I can just go ahead and take the antiderivative of each term separately using the power rule. You add 1, divide by the power. Add 1, divide by the power. Add 1, divide by the power, which is 1. Don't forget your plus c. And this does simplify nicely. I'm going to write that second term as 6x squared. So your answer would look like this. Oops. Okay, next one. Again, we're just going to do each piece separately. So add 1, divide by the power. Coefficient, constant multiple, just stays in the front. Antiderivative of the cosine is sine. And then don't forget your plus c. Okay. Notice I have a trig function, but I've got a quotient. There is no quotient rule for antiderivatives. So somehow you have to rewrite this first. I'm going to go ahead and change everything to sines and cosines, see if that helps. So tangent is sine over cosine. Secant is really 1 over cosine, but I'm dividing it, so that's the same as flipping it, or multiplying by the reciprocal. So the cosines will drop out, so this whole thing really becomes the antiderivative of the sine. Antiderivative of sine is negative cosine of x, and then we have the plus c. One way I remember the signs is when you integrate the sign, you want to change the sign, so that's why it's a negative. This one, again, you've got quotients going on. There is no quotient rule, so you're going to have to multiply everything out. So the top is x to the 4th minus 2x squared plus 1. I still have a quotient, but if you have just one term on the bottom, you can divide each term through by that. So this can be rewritten as x squared minus 2 plus x to the negative 2. Now I can take the antiderivative of each piece, x cubed over 3 minus 2x plus add 1, divide by the power. I'm going to simplify this to be minus 1 over x. There's plus c. Okay. This one here, I would rewrite the radicals with your exponents, and that last term is really t to the negative 3. So rewrite it first, and then use your power rule. So add 1, divide by the power. Add 1, divide by the power. Add 1, divide by the power. Plus c, and then go through and simplify your answer. So this is going to become 2t to the 4th minus 4t to the 3 halves minus 1 over t squared plus c. Okay, last last two. Okay, again, there's a quotient. We do not have a quotient rule. Okay, this, you can use the identity. Sine of 2x is the same as 2 sine of x cosine of x. And notice what happens to the cosine. So really, you're left with the 2. Antiderivative of the sine is negative cosine of x. And then I have that plus c. Last one, notice I have a product. Again, there is no product rule, so you will have to multiply this out first. So I'm going to rewrite this as 2x to the 1/3 plus x to the 4/3. Then you can go ahead and use the power rule. I'm going to add 1, so x to the 4/3, divide by the 4/3. I'm going to go ahead and multiply by that 2 at the same time, so this really becomes 3/2. And then we've got x to the 7/3, divide by 7/3 is same as multiplying by 3/7 plus c.